And the cubic term you see, it will give rise to the higher order IMD, cos omega 1 plus 2 omega 2 term, omega 1 minus 2 omega 2 term, 2 omega 1 plus omega 2 term, 2 omega 1 minus omega 2 term. And among these four things, it is very clear that these two are high frequency terms and they will be filtered out automatically by your amplifier. And these two frequency terms will interfere in your band. Okay, so that has to be carefully designed. That's why the design of LNA is going to be very, very, it should be carefully done. Some frequency terms are diminished, and whatever textbooks you see, the some terms will be completely ignored because they, when you add the frequency, it will go outside the band of your amplifier, and naturally they will be completely filtered out. Only the difference frequency term, they have to be considered, and they will play a spoiling role in the performance of your LNAs. So our goal is to ensure that these difference of frequency terms do not interfere with the fundamental frequency as much as possible. The difference frequency terms are troublesome because they will fall in the band between omega 1 and omega 2. We have taken omega 1 and omega 2 to be very close to each other. Okay, so the different frequency terms will fall either just below omega 1, or it will fall just above omega 2, or it will fall between omega 1 and omega 2. In that case, it is actually a noise, but your amplifier will consider it to be a signal and it will amplify that also, which will cause unwanted noise to be added to your system. So different frequency terms have to be properly eliminated from the system. So for this reason only, we have to have some parameter for measuring the third order intercept. So if I can say if this parameter is having so much of value, then I can completely say all the IMD products are completely eliminated from my system. So for that only, we are going to derive the numerical formula for third order intercept point IIP3 by setting the amplitude of IM3 product equal to the amplitude of the fundamental. So our from analysis we have found that these IM3 products are going to cause a lot of problem to me. So I am going to ensure that the minimum amplitude of my signal should be equal to the amplitude of IM3 products. So this will be the minimum condition where I can ensure that if this is met, I can clearly eliminate IM3 product from my system, because out of all the distortion, this IM3 products are going to be very troublesome to me, because you see here, rather than the some signals what they generate, the different signals are going to be more problematic to me. So omega 1 minus 2 omega 2 and 2 omega 1 minus omega 2, and one more thing, omega 1 minus omega 2. So all these different terms are going to create problems for me. So I'm going to keep IIP3 as my reference to eliminate the effect of IM3 in my signal. See the fundamental signal frequency C1 into A. See here, it is C1 into A. The fundamental whatever amplitude we are giving, it is C1 into A. And the IM3 product is going to be 3 by 4 C3 into A cube. See here, it is 3 by 4 C3 into A cube. So I am equating both to find out a relation where I can minimize the value, I can fix the value of A, which will minimize the IM3 product in my expression. So C1A is the power in the fundamental component, and 3 by 4 C3A cube is the power in the IM3 product. And if you simplify, you get A square equal to 4 by 3 C1 by C3. And A, you know, it is going to be the voltage of your signal. So we have considered a two-tone signal. See here, A into cos omega 1t plus cos omega 2t. So A represents amplitude. So A corresponds to the voltage. So if you fix the value of A from this relation, definitely you can ensure linearity in the operation of LN.